The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to Lab Manager's new Tech Trends webinar series. I'm Tanuja Kopal, contributing editor for Lab Manager, and I will be moderating today's webinar. As the name implies, in our Tech Trends webinars, we will be discussing innovations and trends in technologies with a panel of technical experts from various companies. Today's discussion is centered around innovations in ultra-low freezer technology, and we will be joined by a panel of 4 experts who will give brief presentations highlighting the new features available in ultra-low freezers and what you should look for if you're in the market to buy or upgrade your freezer. Our goal, as always, is to keep things very interactive and to provide you with an opportunity to ask questions and have them answered by our experts in real time. So please feel free to send along any comments or questions anytime during the webinar, and you can do that by typing the question into the question box that appears on the right-hand side of your screen. We will begin addressing all your questions right after our speakers have given their talks. Today's webinar will also be available for viewing on Lab Manager's website, which is www.labmanager.com. And the website also hosts a number of resources such as technical bulletins, application notes, white papers that you may find quite useful. In our closing slide, we will also share with you the email addresses of all our speakers. So you can reach out to them if you need a copy of their slides or if you have additional questions or need guidance on freezer technology. So with that, let me welcome our first speaker, Joe LaPorte, who is a Senior Product Development Manager with Sanyo, North America's Biomedical Division. He has been with the company for 16 years, both in the US and in Canada. Joe has a background in electronic and refrigeration engineering and has previously served as National Service Manager for Sanyo, as well as for national distributors of many lab product categories in the biomedical and lab equipment industry. Welcome, Joe.
Thank you very much, and welcome everyone. Thank you for your time today, whether it be morning or afternoon, depending on where you are. As Tanuja mentioned, my name is Joe LaPorte. I'm Senior Product Development Manager for Sanyo. A lot of our customers and a lot of customers may know us, and some of us, some people don't. We have been in this industry for many years, since the 70s, producing ultra-low freezers. We are very much a very global competitor. We have many ranges of ultra-low freezer designs, but what we're talking about today is specifically what's happened in the industry and where it is going. I'm going to make a very broad overview here simply because I'm the first presenter. And there has been a lot of changes in this industry in the last 10 years. Many of our customers are looking, as many of you may be looking for, is greater energy efficiency, smaller footprint, better uniformity, lower sound levels, greater reliability, and new innovations. And I'm also going to, at the end of this, I'm going to talk very briefly about what the future holds as we see it for ultra-low refrigeration freezers. And I'm going to take them on one at a time here. Energy is a very big issue. In fact, this morning I just got off a very long conversation with the Department of Energy that is looking at standardizing some of these procedures, and I'll talk about that very briefly as I move forward in the slides. To give you an idea of what ultra-low freezers, how much energy they consume, several years ago, the average large capacity upright freezer would consume around 30 kilowatt hours per day of power. If you compare that to a home use unit that you might have in your home for storing meat or other items, to meet Energy Star requirements, they need about they have to meet 411 kilowatt hours per year. So you can see there's a significant amount of energy that's consumed by an ultra-low freezer. Why do they use so much energy? The reason is to cool a chamber down to -80. There is a lot of technical issues that you have to deal with. Some of them are related to efficiencies and how the freezers operate. And what you will find is that every manufacturer out there is looking at how to produce a more uniform ultra-low freezer with better energy efficiency. And as most of us know, if you've worked with ultra-low freezers for any period of time, they do have to work harder than domestic freezers to reach these temperatures. How do manufacturers reduce energy consumption? And more importantly, how do we prove it? The challenge is to maintain performance while reducing energy consumption. when you put product in these freezers, you want to make sure that they're stored at that temperature for years, not having any problems, and that the heat energy that's in those products is withdrawn very quickly. The easiest method to do that as it relates to energy efficiency is to reduce the size of the refrigeration system and put in smaller compressors. The problem is that you need to maintain the heat removal to maintain your critical sample's integrity. So the solution that we're all challenged with is to increase the efficiency of the system without sacrificing capacity. Our approach in the last several years is to introduce a new patent-pending bidirectional flow heat exchanger, fancy word for how we internally in the freezer remove heat energy in areas that you don't see. This is the prime reason that our freezers perform well for energy. We also were able to introduce some new environmentally friendly refrigerants which allow us to use a smaller compressor in the first stage of the systems. If you're familiar with ultra-low freezers, you know that most of them are cascade designs and they require 2 compressors to be able to bring the freezer down to -85 or -80, depending on what your set point temperature is. We also have unique purpose-built compressors with internal oil cooling to drastically increase the efficiency. And we've also introduced a new vacuum panel insulation, which we've been using for many years, but this is a much more robust, a much more efficient design that allows us to get a greater R factor, which means more insulation factor in the walls of our freezers. To look at energy efficiency, for the purposes of today's presentation, I'm showing how we compare to ourselves. From freezers we made just a few years ago, we are producing freezers now that have even greater uniformity, better energy consumption specifications, and allow us to bring our energy consumption on our freezers way down while still being able to increase the performance. For example, our flagship freezer, which is called the MDFU 76VC, uses 36% less power than our freezers in the past, and our smaller unit, the 18.3 cubic foot freezer, uses 47% less power. And the way we've been able to do that is a combination of, as I mentioned, the refrigerants and the heat exchanger designs in the freezer. Some of the most challenging things manufacturers have is dealing with heat exchangers rather than trying to go to smaller compressors to provide the same cooling capacity. The reason I'm comparing to ourselves is that we are finding that there are very widely ranging numbers that we're seeing specified throughout the whole market as far as what the energy consumption of freezers are. Part of that is because there is no Energy Star standard for testing lab equipment. Many of us were involved in this trying to come up with a standard, and we so far have unfortunately failed at that. But as I mentioned this morning, I just had a long conversation with the Department of Energy that is looking forward to moving in the direction of making sure there's a unified standard very similar to what the Energy Star program is. Next issue and next thing that customers are looking for, because very often freezers are now stored in customer lab spaces where in the past that wasn't the case. So footprint has become a very important issue for high density storage, is what a lot of us are calling it now, as in how much space does a freezer take up in the room. Most manufacturers are moving toward vacuum insulation panels on the walls. In the past, the average ultra-low freezer, and still the conventional designs of ultra-low freezers, use 5-inch of walls. You need 5 inches of blown insulation to be able to get enough R factor to be able to give you enough performance on the freezer so that you wouldn't be using a lot of energy and still keep uniformity inside the chamber. VIP, vacuum insulation panels, allow for half the thickness in the walls, which allows you for a larger chamber, more box capacity for the same freezer size. In our case, we were the pioneers of VIP insulation back in the mid-90s, and we're still continuing to innovate with our new VIP Plus insulation. It gives us a lot more storage space in our freezers, and it's been a very important thing for us over the last many years now, and for a lot of our customers. Next thing customers look for is sound level. Since you're now putting them in their labs rather than equipment rooms, customers don't want a noisy freezer sitting in the room. For example, older freezers would approach 72 decibels or even sometimes higher because there's very little sound dampening qualities in the freezers. 72 decibels actually approaches OSHA requirements for having to wear hearing protection, so they used to be very loud. Our freezers, most of our models are now under 50 decibels, so we do provide the quietest freezers on the market as far as the output from the amount of noise you're getting in the room. Next is reliability. Our compressors are made specifically for ultra-low applications. We don't use off-the-shelf air conditioning compressors. We're not using something that you can get off the shelf from a refrigeration wholesaler for your maintenance people. The advantage that we have is we can manufacture design the majority of our key components. So we're not subject to using off-the-shelf components, and we're able to design the freezer specifically for the application. On top of that, for reliability, most of our premium freezers have integrated into them what's called a status alert. The status alert monitors the freezer constantly and monitors many things to determine if the freezer is operating to maximum optimum conditions. And the purpose of that is to give you a very simple indication that there might be a problem with either your loading, ice buildup, compressor efficiency, or something with your voltage that's telling you long before there's a problem that there's something you need to have looked at or look at to make sure that there is not a problem that's going to hunt you down the road as far as your freezer is concerned. There's no complicated menus to scroll through. It's actually very, very easy user interface on those. As far as innovations are concerned, we have a freezer that we're very proud of. We make ultra-low freezers like everyone else. Most of the majority of ultra-low freezers on the market use a cascade system where one compressor cools the next. So the disadvantage of that is that if one compressor fails or one component in that system fails, the freezer warms up. If you're not getting cooling on either compressor, that freezer will warm up to room temperature eventually. Our new DualCool freezers, our MDFU 700VX and 500VXC, offers two completely independent refrigeration systems in the same freezer. So what it does is it allows you to maintain at least minus 65 degrees if one compressor fails for any reason. And for many of our customers, that's been a very big deal for them because they don't have to have people on call if a freezer starts to have problems. They don't have to be there in the middle of the night if there's any issues. Gives you much more peace of mind as far as protecting your critical samples, and we're still able to do that with better energy efficiency than our old Cascade designs. Another thing is it gives us extremely stellar uniformity from minus 50 to minus 86, which is something that traditional ultra-low freezers are not able to do, is give you good uniformity throughout the whole range of what an ultra-low freezer will operate. There's also no filters to clean in this because of the efficiency of this unit, and on top of that, we have some sophisticated monitoring systems of all critical functions on how that freezer operates. So to finish off, in the future, a lot of people always wonder where are manufacturers going. Energy efficiency coupled with performance and reliability are going to be everyone's focus, at least ours, into the future. Inventory management and monitoring methods are becoming very much in the forefront, and what we're going to see in the future, and we see very much in Europe now, and I'm sure all the manufacturers are very aware of this, including the panelists that are on today, is that hydrocarbon refrigerants are becoming very, very popular in most of the world as far as a refrigeration method. They're very environmentally friendly, very easy to obtain. And right now, we're just waiting for the EPA to start opening up the doors a little bit more. They've already started, but we're hoping that in the future that for ultra-low freezers, we'll be able to see hydrocarbon refrigerants allowed into the market. And to finish, I would like to say thank you very much for your time. I posted here our website address, our 800 number, and you'll have my email address at the end of this. So if anyone has any questions or any concerns or anything they'd like to speak to us about, I'm certainly available for anyone. And thank you for your time.
Thank you, Joe, and thanks for getting us started with this good overview about the different factors that people need to consider the freezers. For those of you who may have missed my opening remarks, today's webinar will be available for viewing on Lab Manager's website. The link to the archive webinar will be emailed to all of you sometime next week. But if you need a copy of the presentations, you will have to email the speakers directly, and we will be providing you with their email addresses in our closing slide. So our second speaker today is Michael Paul, who is the Director of Marketing at RURO Incorporated. Mike has worked in sales and training at various companies like Merck and Philips, and he joined RURO in 2009 to oversee their business development and sales strategy. Welcome, Mike.
Hey, thanks everyone for having me today. We're going to talk today about the Smart Freezer, which was developed between Angel and Tony and RURO. Angel and Tony, just to give you a little background, was established in 1932 in Massa Martana, Italy. They have 8 production units located really all over the world and are in more than 70 countries. our joint venture, per se, as a company really came by developing the software that makes the smart freezer go. And so the software that we power the smart freezer with is used by thousands of researchers worldwide and in more than 30 different countries. We're located right north of Washington, D.C. in the town of Frederick, Maryland. Smart freezer at a glance. Really, when you look at the smart freezer, what makes it truly unique is you're talking about a solution that is both minus 80 and also minus 180 degrees. It will accept various types of vials, and it utilizes both 2D barcodes and RFID. So you can use both radio frequency identification or traditional barcoding to read your inventory. Now, where Freezer Pro comes into play, and this is what powers the smart freezer solution, and this is developed by my organization, is that we believe getting the information down to the individual vial is the most important part of cryogenic storage. So people say all the time, okay, how does this solution really work? And if you take miniature vials and you ultimately couple a robotic solution to an LN2 tank, the nice thing about this solution is the simplicity of the robotics actually grabs the individual vials and takes them down and stores them into the discs that you see in sequence. So the unique attributes of the smart freezer we'll go over one more time. A minus 180 degree robotic LN2 tank. And just a point of emphasis there about LN2, it really is the most energy efficient way to store samples. The other nice thing about the LN2 tank is also that it can go 3 days without an external line before you really have to worry about it. So from a reliability standpoint, that's a really nice feature. Again, both 2D barcodes and RFID capable. It's powered by Freezer Pro Enterprise 2012. And the storage capability is between 15 and 18,000 individual vials. The intuitive touchscreen operation is another really nice feature about this. And in summary, really, when we talk about the smart freezer, it's safe, secure, compliant, and reliable. I want to talk really quickly about the user experience and the simplicity of the user experience. When you go to the touchscreen, this is really the simplicity of the smart freezer. You actually go in and enter your username or unique identifier information right there on the keypad to access it. It then recognizes your name and then allows you to load or retrieve the desired sample that you specify right off the screen. When we look at the Freezer Pro solution as it pertains to the smart freezer, Freezer Pro will power not only the smart freezer, but it will also account for the other inventory throughout the lab. So while you're on your laptop computer, your iPad, you can even access this information from a smartphone. You can look at the inventory not only in the smart freezer, but also your entire catalog of inventory throughout other freezers and lines. This better illustrates my point and what I was talking about. You can see here on the left that we have the ability to get things right down to the box level if you were in a traditional upright freezer. But on the right, you can see all the way down to the individual sample as it's specified directly to the smart freezer. And so really the other nice thing about the interface regarding the smart freezer is you really have a built-in LIMS type of experience that provides you all the information that you need in order to take things down to the individual vial. Regulatory compliance, this is pretty standard at this point, CFR, GLP, ISO, CLIA, and HIPAA. Technical specifications, right now there are 2 types of vials that this smart freezer will accept, the 2 and 1.4 mil. We've been told that if somebody wanted to specify another vial that was of smaller dimension, that could be done from a customizable solution. You know, you can load and unload. It takes about 10 seconds per vial to actually go down and pull it out of the LN2 tank. The temperature, again, is 180 degrees Celsius, minus 180 degrees Celsius. Refrigeration is LN2. And it is ported with both Wi-Fi and Ethernet. Is a smart freezer right for you? Well, the time to delivery is about a 5 or 6 month window. There are various purchase options. We offer both a buying plan and a leasing plan. It is a part of the GSA Advantage for those of you that are involved with government contracts. And the expectation set forth is turnkey installation and a 2-year warranty. Currently, the users that are involved at this point are Nerviano Medical Services in Milan, Italy. It's the largest pharmaceutical R&D facility in Italy. DSM GSIT in the Netherlands. And Bristol Myers currently has a demo unit on site and is going to be evaluating this technology. The demo unit is available, and I can tell you right now there is a waiting list. There has been a lot of interest generated with this. As the interest continues to peak with this, we expect that there might be another unit made available pretty soon. For more information, feel free to contact us online. There's the various web addresses and emails. And my personal cellular phone is right down there at the bottom, 301-801-0505. That's all I've got, guys. Thanks.
Well, thank you, Michael. Our third speaker today is Warren Ang, who is Eppendorf's product manager for ultra-low temperature freezers. Warren is involved with a lot of training for new sales reps and dealers. He also helps provide the necessary sales materials and logistics around selling ultra-low temperature freezers and is involved in competitive analysis and market research. Welcome, Warren.
Hi, good afternoon. Today, my name is Warren Ang. I am Eppendorf's product manager for the ultra-low temperature freezers, and I'm very excited here to share the information that I'm about to present to you today. So I hope by the end of my slides that I'll be able to give you guys a better understanding of ultra-low freezers, be able to ask the right questions when you are about to make the purchase in order to satisfy your lab needs. Obviously, price does play a big role in freezer selection, but there are other criteria that should be considered when selecting an ultra-low freezer. So for the next couple of slides, I'll briefly discuss what categories you should take into consideration and how Eppendorf, along with New Brunswick, might be able to satisfy those expectations. So first is to really identify the ideal size of your lab needs. Now let's face it, every lab space is at a premium. So larger freezers obviously will take up more lab space. New Brunswick line of freezers, we range from 3.6 cubic feet all the way up to 27 cubic feet, spread out between 14 models in 120 and 220 volts. The chances are we'll have an ideal size for your space and energy needs. New Brunswick also has 3 individual lines of freezers within their product portfolio, each one with unique strengths to satisfy any lab need. We have the top of the line Nova that utilize vacuum insulation paneling. We also offer now in North America New Brunswick's high efficiency line, or HEF line. These HEF freezers typically have been sold in Europe for 5 years now, but we've finally been able to bring them over to North America. Of course, with a few modifications, because they do operate on different voltages over there. So, and finally, we have our premium line of freezers, which is pretty much a stripped-down version of all the other two, the Novas and the HEFs. So looking past price, let's also consider a couple of things. Let's consider location of the freezer. Where is it going to reside? Where are freezers typically placed nowadays? Typically they're placed in hallways or somewhere in the basement. What about taking your freezers and placing it inside your lab or under the counter space? Just like in the photo to the left, we have an ultra-low freezer that simply fits right under your lab space, and it's in the upright configuration. So that bench under the bench is typically left unused and empty. So ultra-low freezers that can slide under a bench is something that appeals to a lot of people. So it's a great little freezer. It can be stacked even 2 units high if you need to. So you should also ask your local sales rep about freezer performance. You know, we're always talking about performance. We're talking about noise and heat output. Those are always a big concern. Another reason why ULTs are typically placed in hallways. And not all ULTs are created equal. So ask for noise data and heat data. Temperature uniformity should also be a concern. Temperature uniformity is pretty much the delta T, or the temperature difference between the lowest and the highest temperature inside your freezer. So it's more of a peace of mind to you, the customer, that when you set your minus 80 Celsius freezer, that all your samples will also be at minus 80 degrees Celsius, whether it's on the top shelf or on the bottom shelf. Ask about vacuum release provisions. If it's a freezer that is accessed multiple times during the day, you'll need some type of vacuum release method. So I'm sure everyone has experienced the vacuum effect of ultra-low freezers, and that's where the outer door cannot be reopened right after closing it. So some freezers actually have devices that safely relieve vacuum, so you don't have to take a screwdriver to the gasket and risk damaging it. And finally, you also want to ask your sales rep for either a demonstration or a referral. Ask who has one of these units nearby, so that you can open and close each of these freezers. And of course, you know, if a picture is worth 1,000 words, a demonstration could be worth 1,000 pictures. Oops. I'll jump ahead there. All right. The other categories to consider is the type of insulation. There are typically two types of insulations out there. One is vacuum insulation paneling and traditionally foam freezers. Vacuum insulation paneling will typically give you a larger internal capacity, but expect to pay a little bit more for a freezer equipped with this type of insulation. Power consumption has been a hot topic lately, which is typically expressed in kilowatt hours per day. And I'll talk a little bit more about this in a later slide. After-sales service should also be considered a decision within your peers. If and when a unit needs to be serviced, who do you typically run to? The person that you typically run to is the person that that sold the freezer to you. And so consider a company that does have a large direct sales rep base available to answer any of your questions. Consider their direct field service network, as well as third-party networks. You also want to consider their warranty plan. Not all warranty plans are exactly the same. So ask your sales rep about the specific warranty plan that manufacturer will provide. So location, you have a choice. Looking around your facility, most, if not all, ULTs are typically placed in the hallways or in the basement, but it doesn't always have to be the case. You can always fit your ULT freezer inside your lab. All of New Brunswick ultra-low freezers, even the larger 25 cubic foot 725, can fit snug through a single doorway. The other unit, the U101, is our under-the-counter upright configuration. And like I mentioned in the previous slide, that it fills those voids in the labs. Typically, those voids under the bench will typically remain unused unless something is slid under there. The U101s are very popular for clinical trials. Doctors' offices, U.S. embassies around the world uses U101s to store vaccines and emergency use. So these are just some options to you. Sound. You want to consider sound in terms of performance, and sound is typically it's an area that is least understood in terms of testing, because, like previously mentioned, there is no standard for testing ultra-low freezers. So sound is one of those ratings that needs to be accompanied not just with a rating, but also the parameters need to be addressed along with the reading. So when you do ask for sound decibel ratings, do ask for the parameters under which it was tested. So below I have a line chart. It shows typical levels of everyday natural occurring sounds, just to give you a better idea of where, say, for example, an NBS U725 will fall under. We've tested our U725 to be right around 56 decibels, which is comparable to a percolating pot of coffee, but still lower than normal voice conversation. So when you have a freezer in your lab, you won't have to shout to the person next to you. So installation type, this really ties into location of the freezer because of the amount of extra space that you will gain by utilizing vacuum insulation paneling. But I also wanted to state that not all vacuum insulation panelings are created equal. New Brunswick, we offer vacuum insulation paneling using VacuumPort technology. VacuumPort technology, this is the reason why New Brunswick can offer a 12-year warranty on vacuum insulation paneling. But again, freezers equipped with vacuum insulation paneling will typically cost more. But in trade-off, you will get up to 30% more internal capacity on the same footprint. Next, power consumption. New Brunswick has probably the widest selection of energy-efficient freezers available in North America. Efficiency has always been part of New Brunswick's engineering goals because, well, they're based off European standards. And those European standards are typically more stricter and more demanding than here in North America. So New Brunswick takes the energy efficiency story to the next level with a high efficiency line. So our HEF line are among the most efficient ULTs throughout its model range. So what does this mean? Less greenhouse gases emitted to the environment, as well as savings, dollar savings to the facility. So you can roughly save $13,000 for every 25 freezers that you replace in your facility, just in energy savings alone. So, for example, our U570 consumes roughly about 12.2 kilowatt hours per day. All right, and service. The last consideration I want to discuss is after-sales service. If and when the unit needs to be serviced, you'll need a supplier that holds themselves accountable to making the customer whole and to get them back up and running as quickly as possible. And I believe Eppendorf's reputation satisfies that need. So as of 2012, all New Brunswick products are serviced through the Eppendorf service network. All our sales reps are trained to initiate the service process in the event that you do need service, and we'll always see it through to the end. So if we also have a knowledgeable customer service rep base in our call center, just in case you can't reach your sales representative. Eppendorf also employs a team of direct field service technicians that only services Eppendorf and New Brunswick products. And finally, we have an intensive third-party refrigeration network system for rapid response in case a refrigeration issue arises. And as I mentioned previously, our warranty is 2 years labor, 5 years on all parts. We do cover compressors and any parts that may need to be replaced within that 5-year time. So we also warranty our vacuum insulation paneling for 5 years, like I previously mentioned. And that's just to give you the customer peace of mind. And finally, just to summarize, some unique features about the New Brunswick freezers is that, well, every single one of our freezers will fit through a standard doorway. This includes upright and chest freezers, giving you the ability to put freezers inside your lab space. Every freezer is equipped with 2 accessory ports. Can be used for monitoring devices as well as backup systems. Vacuum relief port with ice plunger. This is a unique feature to really vacuum anytime that you need immediate access to the freezer. All of our controllers are flush mounted with microprocessors positioned at eye level for easier reading, and they can easily be set up with password protection. We have a unique gasketing, outdoor gasket system where they are frost resistant. So you don't have to de-ice the gaskets as often compared to other competitive models. Our inner door design are also gasketed and insulated, ideally creating 3 separate compartments, limiting cold air loss anytime you have to access the sample. Our interior is fully stainless steel. This includes the shells as well as the sidewall cabinets. This allows for tighter temperature uniformity and heat transfer, unlike other designs which are typically painted steel. All the compressors and refrigerants are commercially available, so they can be purchased from any supplier. It doesn't have to be directly purchased from NBS or through Eppendorf. And of course, all of our freezer lines are energy efficient, with the HEF line being most energy efficient. And finally, to put it all together, New Brunswick is known for energy efficiency throughout the whole breadth of the product line. Low heat output, low noise output. We have also one of the most durable freezers on the market, which we can back up with our warranty plan. We have unique convenience features, just like the vacuum relief port, and of course we have a large range of sizes to satisfy any capacity and any budget. And I know there's a lot of information here displayed, so if you have any questions, do not hesitate to contact me or your local sales rep. For information, it can be found on our website, eppendorfpa.com/freezers. And I hope you've all learned a thing or two, and thank you for your time.
Thank you, Warren, and thanks for getting us all thinking about all the questions that need to be asked before you put your money down. All right, our final talk today will be given by Godshields, who is the Commercial Director for Cold Storage Products at Thermo Scientific. He has been with Thermo for the past 11 years, working in various marketing and commercial roles. His focus now is supporting the global cold storage business for Thermo, which includes ultra-low temperature freezers, lab refrigerators and freezers, and liquid nitrogen storage products. Welcome, Gordon.
Thank you very much. Appreciate everybody joining today, and very excited to talk about our newest addition to the ultra-low temperature freezer line. Specifically, I'm going to talk about the Revco UXF series. In addition, we sell products under you may know the Forma name, you may know HeraFreeze. So there are a number of different names that we sell the products under. This specific platform is our newest product line in the portfolio. So as we talk about our strategy and what we focus on as a company, and specifically within the cold storage portfolio, there's really 4 key pillars of our cold storage strategy. First and foremost, and you heard a lot about it already today, is the focus on green, if you will, energy savings, and protecting the environment. And this is a key part of our overall strategy as we continue to innovate and develop new products, is using renewable sources and developing products that use less energy. Peace of mind and quality, and we'll talk a lot more about that, key to our customers when we talk about ultra-low temperature freezers. People are storing, in many cases, their life's work, and maintaining and protecting those samples is absolutely critical. So many factors go into making sure that we have a reliable product, including manufacturing processes and the way we've designed the product. Ease of use. Everybody today is getting more and more used to things like iPads and various devices that allow for easier interface, quicker access to information. So this is key in the development and something we've incorporated into the new products. Touch screens are becoming more familiar to people and user-friendly, and that is a part of making sure people have a great experience in interfacing with their ultra-low temperature freezer. Finally, performance, something you've also heard about today, is critical to our customers. Recovery after door openings, capacity, how much storage area you can get in the footprint, temperature uniformity, and noise. These are all things that are common to any supplier, and something that we focus on to make sure we're maximizing. As we look at, we do a ton of voice of the customer, and we do this on an ongoing basis. For those of you that are familiar with ultra-lows, none of this will be a surprise to you, but as you'll see, the key things that we focused on in the development of the new product were based specifically on customer feedback. Quality is a given to any customer, particularly in an ultra-low temperature freezer. As I said before, this is a product that could be storing somebody's life's work. The average value of products stored at an ultra-low is anywhere from $750,000 to priceless. So we take that responsibility very seriously. When we look at performance, we talked about the key things that people are looking at is being able to have very uniform temperatures within that unit to be able to recover. We have many customers going in and out of ultra-lows 15 to 20 times a day, if not more, particularly in academic settings, and we have to quickly recover after that door opening to protect the samples. Price is always a consideration. So as we look at our designs and develop product, we could have the greatest whiz-bang features in the world, but our customers are limited in their budgets and their capability in spending. There's a lot of things that they need to spend money on. So we look at maximizing performance and reliability and quality at the same time with a keen eye on pricing. Storage capacity, your laboratory space is incredibly expensive. So getting more storage in a smaller footprint is critical, and that's a key part of the new design. And then finally, as I mentioned before, the interface, so ease of use, information flow, and ability to get information from your unit very quickly is critical. So this set the stage for the development of the product that we introduced last August. As we go and we talk about this, these are the key things, and we use a little acronym. Sometimes we use PEAK as an acronym that talks about the key aspects of this new product of the UXF series. That's performance, energy, ease of use, and capacity. So those are the kind of key areas that we focus in on. And as you saw from what I described, this is specifically tied to what we've learned from customers, that customers are most important to them. This gives you an idea of some of the key features from a construction standpoint of the new unit itself. Very robust cabinet. The door handle itself is a key part of the interface. So one-handed design, easy to use, and yet gives very good solid opening and closing of the door itself. You want great compression on that door seal to prevent any kind of leakage. Also, we have several different locking systems. Not only a keyed lock is standard, the ability to put a padlock on the unit is also standard. And then as an accessory, we have an electronic key card system that allows for a greater level of security and monitoring of who goes in and out of the unit. Door seal, absolutely critical in an ultra-low. Our door seals are very specialized and designed. 4 points of contact, 7 zones of sealing. So a very effective door seal. You heard others talk about the vacuum insulation. We utilize a newer technology in vacuum insulation, and we combine that with blown foam because you want to make sure you're filling all the voids. So you can't just have vacuum insulation, you need foam as well. And we use, not only do we use a high grade of foam, but we use a much more greener foam called water-blown foam, which has no blowing agents that can impact the environment. Vacuum relief port, we have a heated vacuum relief port. We do such a good job of sealing the unit that if you don't have a vacuum relief port, I think as Warren mentioned, you can't get in and out of the unit. So that's critical. Interior doors, our doors are insulated. We use a rare earth magnet for very good sealing, and they give very, very good protection to the samples. And then finally, stainless steel shelves that are reinforced to be able to hold the loads that people are putting in and out of an ultra-low. So if we look at the units themselves, we talked about in the new design, we really focused on improving the overall storage per footprint. And in this particular unit, what we've done with 5 different sizes, we have focused on what most of our customers use in sample storage, and that's 2 milliliter vials in 2-inch boxes. So we've maximized the storage capacity around what our customers use. And before you hear people talk about cubic feet, that type of thing. What we really focus on and use actually in our model numbers are box capacity, because that's what our customers are focused on. So in this case, what you're looking at is the unit design. Every unit has the same height and the same depth. The only thing we change is width, and that's based on the rack design itself. So we have a model 300 that holds 300 boxes, 400 that holds 400 boxes, 500, 600, and then the largest capacity unit in the marketplace holds 700 boxes, 70,000 2-milliliter vials, or 119,300 1-milliliter dense storage vials. So again, great capacity in a much smaller footprint. All of our units will go through a standard 36-inch doorway. So no modifications to be able to get any of these units in. When we talk about energy, a lot of discussion about that. And what we've done with these new units is we have not only improved our energy use compared to our older units, so gotten that energy use down considerably while still maintaining, actually improving overall performance. We also have a great feature, an energy savings mode. So you can actually operate these units in high performance mode, or you can use them in energy savings mode. The only difference in energy savings, it has no impact in the ability of the unit to recover after a door opening. It only impacts the cycle time, which gives a slight variation with regard to uniformity. So if uniformity is critical to you, you would want to run in high performance mode at still a considerable energy savings over older units. Or if that is not a critical factor to you, you can still operate in energy savings mode for even lower energy. So that's a very innovative feature on the new units. What's really exciting about this unit, sample protection we talked about, greater capacity and energy savings, but the user interface is what really makes this product unique. And what you're seeing on this screen is what we fondly call the circle of life. This gives you access in a very intuitive manner to all the operating aspects of the unit. So this is where you can access freezer settings, user interface, backup systems. We have 5 different languages that the unit will operate in, so from a global standpoint, we can operate in different languages. And this is where your alarm test and other information is available to you. The key screen that you would normally see would be this one here, which is going to give you the basic, here's what the temperature's at, and also give you a charting similar to a chart recorder of the temperature variation, so that you can see at a glance where the unit is operating. You'll also see there a blue heart, and I'll talk more about that on the next slide. But this is our basic health monitoring device. Very simple visual display of how the unit is operating. When the heart is blue, everything is good. So that's the aspect that we take. If you look at the different indications from the heart, a blue heart, status okay, that's where you want it to be. A yellow heart is an indication that, hey, you need to take a look at the unit. Something is going on. It could be one of the components is operating out of range. It could be that we have a extreme ambient, so the lab is too hot, and that's going to have an impact on the operation of the unit. Finally, a red heart is an indication that something is wrong. So that is a situation that takes immediate action. We've got a warm or cold alarm based on settings. We have a door open that's been left open, or we have a power failure. And in those cases, then, you need to be able to take quick action. What's really also interesting about this is the ability to easily access a variety of information at a touch of a finger. So we can look deep into the unit as far as different operating temperatures, where we have monitoring devices on all the key operating temperatures and aspects of the product that help to give a predictive failure aspect to the product. We also can access things like information with regard to any alarms. And what's really interesting is the ability to access information with regard to door openings. So I can go in, very quickly find out when was the last time the door was open and how long was the door open. If we're using our accessory security device, I can also tell you who opened that door and how long they had that door open. So there's some really nice features with regard to this. The other great thing about it is we can see information right on the screen. We can also download that information through a USB port right in the front. We maintain up to 15 years of data. So not only event data, but also temperature data. We take a reading once per minute, and we've got that information that then, from a diagnostic standpoint, if there's a concern over the operation of the unit and the person happens to be in a remote location, they can download that information through the USB port and then email it to one of our technicians. We can quickly diagnose, get somebody in there without an additional sales call or service call to be able to diagnose and quickly fix the unit. So these are some really unique features to the operation of the unit itself. We've got a number of ways to be able to access this information. One of the fun things that we've done recently is a video that in a entertaining way illustrates the aspects of the new unit called More Than a Freezer. So you can see on the screen here, basically you can go into www.thermoscientific.com/more-than-a-freezer, get an opportunity to view our video. We also have basic product videos that are available on that site as well. If you want more information, an easy to fill out form can be completed, and then we will make sure we contact you. We sell our products through Fisher, through VWR, through Cardinal, and through a number of independent selling organizations in various parts of the world as well. We have a direct sales force in each geography of the world that's there to support those dealers and to be able to also answer any questions or provide you with additional service or information. So I think with that, we can go to the next slide, which I think gets us to the end and the question and answer period.
Great. Thank you, Gordon. Sounds like a fun video. Well, let's begin by addressing some of the questions that have come in. I just want to remind you that some of the questions do touch on issues that some of you may have already addressed in your presentation, but I want to bring up those issues again because obviously they are important to our attendees, and also having the opportunity to discuss it during the Q&A gives everybody a chance to provide their perspective. So with that, let's start with the energy savings, because all of you talked a lot about energy savings and how it's important. But in all fairness, and based on questions that have come in, how does energy savings actually translate to cost savings? So who wants to go first?
Yeah, I mean, this is Gordon. I can start out, and I'm sure the other guys have answers too as well. I mean, one way to kind of illustrate an ultra-low temperature freezer and how much energy it uses is it's similar, particularly if you look at, I think Joe showed some slides where in the past you had ULTs that were operating 25 to 30 kilowatt hours per day. That's on the magnitude of the energy usage of a small home, to give you an idea. So if you think of a ULT as using the energy of a small home over the course of a year, you can start to then understand the savings that can be had by getting 15, 20+% in savings. So that equates to $1,800 to $2,000 a year. That's that kind of money for a small house and an energy standpoint. So you can get hundreds and hundreds of dollars in savings by replacing old freezers that are running inefficiently or by replacing freezers with new technology.
Okay, thank you, Gordon. Anyone else want to?
This is Joe here at Sanyo. Gordon made a very good point, and that's a good analogy as far as how much energy these freezers are consuming. And a lot of people aren't aware of it because very few people are paying for the energy in their lab except in a small organization. And it's where we've seen this come from is the university system in California that was looking at the energy costs in their on their campuses. And if I remember correctly, the number was something like on a university campus, it can approach 40% of the energy usage is just on lab equipment. So a lot of them started drilling down and looking at, well, where is it all coming from? And there was a lot of efforts put through Energy Star and right now the Department of Energy to look at, okay, what's going to be the standard for this and how much energy these products are consuming. But it has been an issue for our customers. As many of you that have large equipment rooms, there is air conditioning handlings that have to be dealt with as well, as far as how big does the air conditioning system have to be and how many freezers can you put in a room, and everyone has to address that issue as well. So when it comes to energy, especially as it relates to ultra-low freezers, it is one of the largest consumers because of the design of how they're made to be able to store at minus 80 degrees, and that's something that we're all trying to address. Right now, though, the standard on that everyone is using is a little different depending on who's doing the testing and how they're doing it. So all of us are working toward coming up with a standardized test procedure so that when we represent our numbers and our energy consumption, they're all on the level playing field.
Yeah, and Joe brings up a great point too, is you can't just look at the energy savings or the energy use at the plug. The other key aspect is called heat rejection, and that's, you know, we've all stood in front of a refrigerator and felt that warm air blowing out. Well, that's called heat rejection, and that's also part of the cost. So the less energy you use at the plug or at the unit, the less typically heat rejection you have, and that's an additional considerable savings, can be as 30–40% of the cost, because the heat you put out into the room then has to be removed through your air conditioning systems.
This is one,
the one thing that I'll comment on is obviously the curveball in all this is an LN2 tank, and when you have a robotic solution, you obviously have, you know, really taken a lot of the safety issues out of the equation, although you're not dealing with quite the high density type storage that the other units have. You're talking about an LN2 tank, which is, you know, a different animal altogether and extremely energy efficient.
Right. And let me come back to the LN2 tanks, but you know, I'm glad you have brought up the heat output, because that is you know, here among the series of questions that have come in. So obviously the more the heat rejection, you know, more cost for air conditioning the room. But what happens to the heat for especially your under-counter freezers? Where does that heat go? Is that something that we need to be concerned about for the under-counter units?
This is Warren. The under-the-counter unit operates just like any other ultra-low freezer. The only difference is the under-the-counter freezer does not need the space behind the freezer to have proper ventilation. Ventilation goes in and out through the front of the freezer. So again, the heat rejection of the freezer into the lab space will be typical of any other freezer. It will expunge the heat into the surrounding environment.
Got it. Thank you, Warren. So coming back to the LN2s, Michael, so how much LN2 is used per month or per year? And can you elaborate on how exactly it is more energy efficient than some of the other models that we talked about?
Really, the initial install is what takes the most LN2, but it wouldn't be more than 20 liters in a given day to power this unit up. It really doesn't use a lot of LN2 tank once the level is established. It's really works just like any other LN2 tank that you'd have in the lab. There's nothing really novel about this particular unit other than, of course, you have rotating discs that are down inside it. But if you look at the requirements for LN2 consumption with any other tank that would be of similar size, you would find that it would be almost identical.
Okay,
yeah,
thank you.
When we talk about liquid nitrogen storage, there are a couple of key things that impact how much liquid nitrogen that you use. One is your storage method, so whether you're storing in liquid phase or vapor phase. The other is essentially the neck or the diameter of the opening, because liquid nitrogen will burn off and basically evaporate, and so putting more product in and out of it, and then that neck size is a critical aspect to how much liquid nitrogen. We make a number of different liquid nitrogen storage products, anything from small manual fill type product all the way up to the very large stainless steel repository tanks that will hold hundreds of thousands of samples. So the key is really how you manage that and design those units.
Sure.
And
And
this was Gordon,
the
correct?
neck-
Sorry, I have to interrupt to find out who made that last comment. That was Gordon from Thermo, correct?
Yes, I'm sorry. Yeah.
That's okay.
Thanks, Gordon, for the input there. And the opening on our LN2 tank is about an inch in diameter, so it has a very small neck and opening into the LN2 tank.
Okay. So since we are talking so much about heat and energy savings, so here's a question, more of an engineering question. So for the upright freezers, why not have the compressors and mount it on top of the units rather than at the bottom?
This is Joe at Sanyo. That's a good question, and from our perspective, a lot of it relates to how much noise you're hearing. For those of you that have laboratory refrigerators where the compressors are on top, right up where your ears are, you're going to hear more noise than on the ones that are on the bottom. That becomes a critical factor. There's another that's probably more important from an engineering point of view is all of these systems, because of the temperatures they're running at, are very has some characteristic effects on the oils and the refrigerants that are in them. When you have the compressors on the bottom, it allows the oil to migrate back to the compressor. It allows the refrigerants to get back in a very efficient way. And that's related to how the evaporators or the cooling coils are put in the walls of the freezer. And everyone's using a method, or for most of us anyway, are using a method called downflow evaporators to make sure that everything gets back to the compressor where it belongs. So ultimately, it increases the reliability of the units by having them on the bottom. And the secondary effect is it reduces the amount of noise that you're hearing in the room.
I see.
Yeah, this is Gordon Shields. Finally, the practical thing too is that you've got a lot of that weight. I mean, that the compressor in the refrigeration system is pretty heavy, so putting it on the top is also really not practical for the reasons Joe mentions, as well as just an overall top-heavy type situation.
Mm-hmm. Okay. All right. What about energy for water-cooled freezers? What's
This is Joe at Sanyo. The energy consumption that we've seen traditionally on water-cooled freezers, and in Europe, they're, at least from our perspective, they're much more popular than they are in North America, although there is some ground being gained on that here. We're finding that there is better energy consumption on the freezer with a water-cooled freezer than we will with a standard cooling on a freezer, standard air-cooled freezer. Plus, you get the added benefit of the fact that a large percentage of the heat that we talked about earlier that's being rejected into the room is actually being absorbed by the water that's being moved out of the room and can be used for other purposes. We see that quite often in Europe. So yes, there is definitely an advantage to that.
Yeah, this is Gordon Shields from Thermo. We offer a number of different products with water cooled, and that the biggest benefit that we find is, as Joe said, in the heat rejection. There's some advantage in the energy at the plug, so to speak, but it's really more in removal of heat and then that savings on your air conditioning system where the biggest advantage in water-cooled systems are. And people have to keep in mind a water-cooled system is an investment because it's not practical to just run tap water through a system. It's typically tied into a facilities design where they have water cooling towers, and it's part of the overall facility. What we're seeing is as more and more energy efficient facilities are being designed, that's something that people are incorporating into their newer designs. It's typically not a practical feature to try to implement in an older facility.
Got it. Warren or Michael, anything to add to that?
This is Warren with Eppendorf. I agree with Gordon. Typically we've gotten requests for new labs that are speccing in water-cooled units, and yeah, it's just a logistical nightmare to try to integrate a water-cooled system into an older facility. And typically the older facilities are the ones that are already maxing out their heating and air conditioning system, and that's why they're looking to get other alternatives in terms of heat rejection, not into the air, but into a liquid medium, either through some type of recycling chiller system or through some type of recycling hot water system where hot water will now de-ice the driveway in the facility's parking lot, for example.
Oh, interesting.
So there's many different applications for the water-cooled units, but typically we've only been seeing them in new labs or new building scenarios.
Okay. Well, there are other sort of energy-related questions, but I just wanted to shift gears a little bit and talk about temperature uniformity within the freezer. So the question is, most of these freezers are packed to the gills with hardly any empty space left. So do you think, that would impact how, the air flows within the freezer, and will it impact temperature uniformity? And what about some of the other factors that can influence temperature uniformity as well?
Mm-hmm. Yeah, this is Warren with Eppendorf. Yeah, you mentioned that freezers are typically packed to the gills, and that's actually a good thing in terms of uniformity. The more you pack a freezer, the tighter the uniformity is between the top and bottom and left and right. And also, another benefit to having a large packed freezer is that if in case it does need service, it will hold temperature for longer periods of time than a freezer that's empty, for example. And this is one of those criteria that needs to be defined in testing uniformity, energy efficiency, and that's how packed or how full does the freezer need to be able to provide accurate data to customers.
Okay. Anyone else wants to add to that?
Well, that's actually,
Yeah, I mean, really, what it...
Oops.
Well, go ahead, Joe. Go ahead.
No, I've been talking too much as it is. Yeah, that's a very good point. The more full the freezer is, the more efficient it's going to be as far as keeping the uniformity tight. Our freezers typically at -80 will give us at least plus and minus 5 degree uniformity, which is what a lot of customers are looking for in a GMP application. And our 700VX, our dual compressor system, our dual cooling system, will actually do that kind of uniformity and better throughout the whole range, -50 to -80, and an empty freezer, which is where everyone tests, at least in the GMP applications. Everyone's going to test it with an empty freezer to make sure that it's worst case scenario. But the one thing you really want to do as far as uniformity, if you're really concerned about it with your product, is keep the ice buildup, the frost buildup off the walls on the inside, because that's going to affect your heat transfer. Gaps in the doors, anything that's allowing heat energy to get through the doors really does make a difference as far as uniformity and trying to maintain that level of uniformity inside the freezer.
Yeah, and this is Gordon, just to add to that. I mean, there are a number of things that can impact uniformity, and it goes back to the overall refrigeration design, where your control probe is located and how quickly the unit will react to a door opening, for instance. And what we always focus on is, and what customers are most concerned with, is variation on the warm side. Clearly, they're less concerned, and in some cases they have very strict plus or minus parameters, but most people are concerned, again, with sample protection. So what we always do is in our refrigeration designs is minimize any variation on the warm side. If we give it all, it's to the cold side to make sure that we're protecting the samples.
Okay, thank you, Gordon. Sorry. Now, the next question is about this new Stirling engine freezers. I guess that is for, what is it, like storing human embryos and so on. So does anyone have more information about those types of freezers?
Yeah, this is Gordon. I can address that a little bit. We're familiar, have done a lot of research into Stirling. Stirling is just another way of, if you will, removing heat. It's another method compared to a standard compressor system. The units themselves, they're difficult. A Stirling engine can be difficult to build. There are technologies now that have improved the overall reliability of that design. We have yet to see, there's some companies out there that are working towards developing a larger version of an ultra-low temperature freezer, but I would call that still in somewhat the experimental stages. It is an interesting technology, though, because if it's perfected and we're able to use that, then you can significantly reduce energy savings or reduce energy usage as well. We've seen units out there, prototype units that use the energy of 2 light bulbs. But I would say at this point it's still not a viable technology for general use.
Okay, good to know.
This is Joe at Sanyo. We have a very similar approach with that as well as what Gordon mentioned. In fact, several years ago, we had a product in some of the overseas market that used that sort of technology. That technology has actually been around for a very long time, and as Gordon mentioned, it's one of those things that there's a lot of technology involved in that, and our concern for at least for very low temperature applications was reliability. So it is something that we have worked with. It's something that we actually produce ourselves, but not for this application because of the technical barriers on it.
Okay. Right. Well, I just wanted to mention that, Lab Manager magazine also conducted a survey on freezers a few months ago, and, price point is always an important issue, but we were surprised to see that service and maintenance was very high on the list in terms of what people were looking for. People were tired of, accumulation of frost and worried about moisture control and access to filters and compressors just for routine cleaning that needed to be done. So can each of you just take some time to talk about what people really need to do in terms of routine cleaning and maintenance, and just to keep the freezer alive for a long period of time?
Yeah, this is Warren with Eppendorf. I always recommend a preventive maintenance at least once a year. That typically a PM typically includes a defrost cycle. Obviously, you'll have to remove your samples and temporarily store it in another freezer. But de-icing the interior, the gaskets, the inner doors, any of the cracks and crevices within the freezer cabinet, that will prolong the life of the freezer. Cleaning out any air filters, making sure that the outer door gaskets are maintained and are not torn, because any little leak in the outer door gaskets will have a lot of cold air leaking, and that will mean your compressors are going to work that much harder to maintain temperature. So anytime that you have the ability to do a preventive maintenance, I would recommend it, and also just keep an eye out for any gaskets that might be leaking or torn.
Right, but as we talked about earlier, these freezers are packed to the gills, which means that they are never really going to be at a point where we'll have few samples. So this preventative maintenance involves taking out all the samples, storing them elsewhere, and then cleaning out the freezer. Correct?
That is a preventive maintenance that let's say is like a 100% PM service. If you are not able to relocate samples, I would still try to de-ice as much as possible. Inner doors, inner door gaskets, anything that you can reach from the outside of the freezer without actually removing samples. Anytime you can remove frost, that'll be a benefit towards the life expectancy of the freezer. Same with the gaskets. If you have ice buildup on the gasket, I would recommend removing that ice as soon as possible. Don't allow it to get to extreme levels, because once the gasket is overrun by ice, the gasket is no longer effective, and you'll have constant cold air leaking throughout the freezer, and of course that affects compressor life.
Okay.
Yeah, this is Gordon Shields. I mean, there are a couple things. Warren mentioned that the key things is keeping ice off the gaskets. Unfortunately, when you think about this, when you open the door of an ultra-low temperature freezer, you've got at least 100 degrees C differential between the interior and exterior. So there's no way to prevent, condensation. That is a natural fact with that kind of temperature differential. So the key is to, number one, is in designs have a unit with great door sealing capability and door seals, very good inner door as well, and insulated inner doors. That helps to minimize that. And then regular maintenance, keeping that ice off the gaskets. The other key thing, and people, just like your home refrigerator, is keeping the filters clean, because you'd be amazed how much air will get sucked in there and clog up those filters, and then your unit's not going to operate efficiently. The other part of it that people may or may not think about that is a preventative maintenance factor, and that's in the everyday use of the unit, and specifically with regard to length of door opening. The longer you keep that door open, the more you're warming those samples, the more you're getting an air transfer, and the harder you're going to make that ultra-low temperature freezer be used. So we always recommend to customers, think before you go into that freezer. Use a racking system and inventory system that is more efficient, so that it's easier and quicker. For instance, sliding drawer racks that we offer that allow you to quickly access samples, and then know what you're going to do and get in and out of that unit quickly, because keeping that door open will have an impact ultimately on sample protection and on the life of the unit.
I have something that I'd like to chime in with. This is Mike from RURO, and it really ultimately comes down to the process by which samples are stored. And so, obviously we don't have traditional freezer maintenance because it's an LN2 tank. The other piece of the equation as it pertains to the life cycle of the freezer is how inventory is actually moved throughout the process. Because you're removing individual vials in a sequence of up to 5 currently at a time, you're very inventory specific. And so where a traditional freezer, obviously you're dealing with maintaining the compressors, ultimately dealing with the filters, seals, de-icing it. Really, that's one of the beauties of the smart freezer, and it truly is a selling point for our unit in terms of the type of maintenance involved. Really, the only thing to be concerned about from a maintenance standpoint with our unit really revolves around the robotics side of it, and the robotics application is very, very simple, and it's something that that we cover service on. So, it's certainly something to consider.
Absolutely, that's a good point. And speaking of inventory management, do you see any improvisations in accessibility? Because that seems to be one of the biggest challenges, which leads to just the regular upkeep of the freezer. Are your companies working on some novel ways to access the samples where you don't have to go through the whole stack up in front to get to a sample that's stored all the way at the back?
I'd actually like to address that. That's the focal point of the smart freezer, number one. That's exactly what we do. We take everything down to the individual files, so you're really only accessing the inventory that you're going to use in that moment. The other thing, whereas a lot of processes revolve around somebody going and pulling an entire box out and then sorting the inventory when they get to their station or putting it on dry ice, you're not really exposing your inventory that you're not necessarily going to use. You're not opening a box and counting sample vials or scanning vials, or even, for that matter, running them by an RFID antenna. Everything that we do at RURO and everything that we're working on moving forward really revolves around not only this smart freezer type technology and a robotic LN2 tank, but everything moving forward that we're looking at, even at a -80 solution, is going to take everything right down to the individual vial. We believe that all inventory storage is ultimately going to have to go this way in order for large biopharmaceutical companies to meet the ever-changing demand of getting the research processes and drug development down under 10 years. It's currently sitting at about 15. So being able to track that inventory and being able to do it with a web-based system like we do with Freezer Pro is really what we see as the most viable solution. The nice thing about the software platform, yes?
No, sorry, I mean, with the smart freezer, it was fairly obvious as to how you manage inventory. I was really curious to get feedback from the other panelists, because they're models seem the more traditional kind where people really had to go in and get samples out. So Joe, Warren, or Gordon, how are your companies addressing the accessibility issue?
Yeah, this is Gordon. As far as access and quick access, we have to always balance cost versus benefit. And so right now, from the standpoint, from a budget standpoint, doing an elaborate methodology of moving samples around within the unit is beyond most customers' financial capabilities. So what we focused on is doing it in as practical a methodology as possible. First and foremost is with racking. So instead of a typical side access rack, which was sort of the traditional way of getting samples in and out, we really recommend sliding drawer racks. It minimizes the amount of samples that you're going to be accessing and gives you much quicker access to that. And then in addition, through our sister companies, Thermo Scientific, Nalgene, and Nunk, they have a number of different storage sample capabilities, not only tracking software and inventory software, but also 2D barcoding or 2D vials that you can run over and quickly identify and access samples. So that's the practical or lower cost method way of being able to increase the inventory capabilities and access.
This is Joe at Sanyo. I agree with Gordon completely. I think most of us have those applications either through our own companies or working with other organizations that are able to do that sort of thing. It seems that as we get to the larger freezers and the larger racks, in some respects, we don't want to be able to take the entire rack out of up to 24 boxes out of the freezer to be able to get it to one sample. The sliding drawer racks actually make it much easier for customers to access a particular sample they want, be able to move in and out of the freezers very quickly. So from a practical point of view, as Gordon was saying, that tends to be what our customers are gearing toward, is just moving in that direction.
And final words, Warren?
No, I completely agree. We do see a shift in the different types of racking from the big pull-out style to the individual drawers.
Okay. Well, there are a lot of questions that have also come in which are very, very specific to all your companies and your products. So, what I will do is probably just forward those questions. But unfortunately, we are at the end of our webinar time. Thank you all for your time and attention. To the audience, thank you all for your questions and comments. Just a reminder, definitely note down the contact information for all our speakers, which appears on your screen, especially if you need a copy of their slides or if you have additional questions about their freezers and, if you need any guidance on how to go about buying or upgrading your systems. On behalf of Lab Manager, I will definitely thank all our sponsors, Sanyo, RURO, Eppendorf, and Thermo Scientific for their participation and support. And my sincere thanks to all our speakers. They have definitely put in the time and effort to turn a very product-centric webinar topic into a discussion that was really very interesting, informative, and very relevant to all the users. So the webinar will be archived on Lab Manager's website for at least 6 months. So do take the time to visit us online to review this webinar or past webinars. And you can also get information about our upcoming topics on our website. We will be actually taking a short break with our webinars to accommodate our users and sponsors who will be busy preparing for the PITCon conference coming up in a few weeks. So our next webinar will only be on March 27th. And there we will be discussing the challenges around chemical inventory management. But until then, goodbye to everyone and good luck.